Matt, does that not just terrify you? Like I literally jumped back from my seat. I almost fell over. I thought that maybe John Galloway was going to have to jump in.
I don't know. I mean, that was actually pretty jamming out. I mean, we're gonna have to make it. I saw John before. He wants to make it his alarm clock, wake everybody, wake himself up. I agree. I'm gonna record that, and yeah, it's my new go-to to wake up with.
It would like terrify you and yet be absolutely delightful to wake up for. I mean, you couldn't, no one could see because the video is playing, but I literally jumped back. Oh, this is really, I want to make a really cool note too. See how you have that little tiny orange blip in the top up there? That means your webcam's on. You're on a Mac.
I'm on a Mac.
Yeah, look at that.
How do you get rid of that?
You can't.
You don't.
It's a security feature. Now everyone knows that you're really doing it live.
I'm doing it live. I'm on a Mac. It's there. Yeah, I've always noticed that. I thought maybe with a PowerPoint on it might get rid of it, but nope.
No,
we're here.
We're here. It's happening. What are we talking about today, Matt?
Oh, James, we are going to be talking about microservices, but even better than microservices, microservices with .NET. So what could be better?
They're like a service, but micro.
Super tiny.
Not mini. Micro.
Tiny. Not mini services, microservices.
Not small, really neat. Not medium, not large, micro.
Micro.
They don't even sell shirts in micro sizes. So that's how small they are.
That's how small they are. I mean, they're atomic. You know what? They are totally atomic. We'll get into that. That's awesome. Yeah, totally microservices.
Well, I am James Montemagna. I'm a principal PM manager over here at Microsoft on the developer community, focusing on .NET. And I work with you, Matt, like every single day. And it's always a joy.
Yep. Well, I'm over in the cloud advocacy team, heading up the .NET cloud advocacy, and you're over in DevDiv doing .NET community. I'm doing .NET on Azure. There's a lot of mixture there. So yeah, we are working together all the time. Yeah. And actually, Nish on your team and I built this module up. So more collaboration.
Yeah, and I think the cool part too about microservices is that we're going to show a bunch of demos actually at the end where you can just use microservices to kind of make your development even easier. But when you want to deploy your application, wherever you want to go, maybe it's a cloud or on-prem or whatever, wherever you're going, it makes it really easy to deploy and do a bunch of really cool things. So I'm going to show a bunch of stuff off. And of course, we're monitoring the chat room. We got John Galloway over on the Learn TV, and we got us right here on the YouTubes and the Twitches. So feel free to leave your comments and we will totally get to them. But I'm super excited because I actually did this module when you two are writing it together and you have a whole series of microservice modules on Learn. I didn't know anything about microservices. So I took it myself and the follow-up ones that you did. So I'm super excited to follow it again with everybody here.
Yeah, they're a lot of fun. And what I liked about it too, I learned a lot. Nish is like the premier microservice person that we have. So I learned a lot from him, but yeah, these are nice, easily digestible ones. And if you want to follow along, just follow that AKA MS short link, microservices / let's start over. Microservices - ASPNET core. So that'll bring you right out to the module that we're going to talk about today, James, and you can follow right along with us.
I'm doing it.
So, yeah. So what are we going to learn? Well,
stuff.
Yeah. 3 big bullet points that we're going to have everybody take away today. And the first one is we're going to explain what microservices are. Not the mini, not the medium, but the tiny one.
Micro. Boom.
Yep, micro. And we're going to, microservices, there's a ton of different technologies in there. There's a ton of different terminology involved in there. We're going to explain what they are and how they all fit together and what they relate. And along the way, we're going to be building up a microservice with .NET.
Yeah.
So .NET is super great to build microservices with, and we'll actually explain why that is. And as we said, as you can go along, Microsoft Learn all up, not just this module, but all up is a great way to learn pretty much anything that Microsoft has to offer, whether it's .NET, Azure, even if you want to get into the Power Platform or M365 or Azure, on the admin side, there's stuff out there for Learn for you to take. So yeah, check it out. It's interactive learning. There's videos. You can even prep for exams, certification exams with it.
Yep.
Yeah.
All sorts of stuff. And in fact, this year, we launched over 35 new .NET modules. That's literally one almost every single week. I mean, I know there's 52 weeks in a year, but 35 is pretty good. And that's
Yeah.
across all different bits and pieces. We just launched a brand new minimal API. So you're looking to get started with web APIs in the backend, which are great for microservices. There's a whole learn path available, and that's multiple modules. Also, Blazor to build interactive web applications. That's up there as well. Of course, if you're building mobile desktop applications, we got some Xamarin's, got some UWPs, we got some Razor pages, we got some microservices, we got the SignalRs, we got all the things. You can actually go to the Learn page, and it says right there. I'm going to go to it right now. I'm going to go to docs/learn. When you go to products, you'll literally see a button that says .NET. When you tap on that, everything is there. So if you're just getting started, you're brand new, and you're like, wow, James tweeted this thing, so I guess I'm going to watch it, but I don't even know what he's talking about. You can go learn C# right in the browser. You don't even have to install anything. It's super cool. So go check it out. docs.microsoft.com/learn/.net. That's actually what it is. So.
Yep. And you forgot the Visual Studio ones where you can actually learn about testing using Visual Studio.
Oh, so, and Git and GitHub as well. They put that in there too, which is a good one too.
Yeah. So tons of them. I mean, it's all this goodness where you can just pick up, learn a ton of .NET from beginner all the way to advanced stuff. So yeah, definitely check it out. And today, James, as evidenced by that orange dot in my upper right corner, we are live, we're interactive, and we're monitoring the chat. So come and say hi.
Come say hi. We got Steve in the chat. We got Handy in the chat. We got Rob in the chat. That's all we got in the chat right now. But I'm sure there's more people around. And as we go, I will continuously drink this Aqua Kefir probiotic water. It's orange, peach, and mango. $2.99 at local Trader Joe's. Not a sponsor. Not a sponsor.
Not yet. Not yet.
Xtechna also saying hello in the chat. Hello, hello, hello. Yes. See, it's live. We couldn't do that if it wasn't live.
That's right. Proving it once again. So
exactly.
Here we go, James. The intro to the whole module. We finally got around to it. So microservices. Now, James, do you remember way back when we started programming that we would build just like one huge monolithic application? Just everything, like the kitchen sink and everything would go into this thing.
Put it all in there. Everything in the box. It's about 28 projects. They're all interdependent upon each other. Just you deploy everything on one server, and that scales super good.
Yep. If one thing went down, it all went down.
I mean, it was flawless. Awesome. Yeah, it makes a lot of sense. I mean, you just reboot the whole thing, and the whole thing comes back.
Yep. And even better, the code was so mixed up. Like, we're going to be showing like this, how to build like this pizza, Contoso pizza today. But like, if you had like a menu component interact with your order component, it could all be in like even the same project. You know, this billion lines of code, you can never find anything. Yeah, it was great. Life was great being a developer. But I'm being sarcastic. Life is even better now. And then we have microservices. And what microservices let us do is that we can break up individual parts of our application. So as I alluded to, we could have a order part of our Contoso pizza application. We can have a menu part of it, and it can be completely different. They are completely different. They just focus on bringing back the menu or taking the order. And then we can scale them up and down. We can deploy them separately. They're, for all intents and purposes, James, completely different applications.
Yeah. And I think a good example of that, you know, I've been always a person that wants to get the latest video game console like on day one. And, you know, back in the day, we used to go in person to GameStop or whatever, Best Buy, and we used to stand in line and get them. And everything really shifted online. And if you remember, like Black Fridays and like really big console launches, you would hear these stories of like entire websites going down and the whole internet's down, blah, blah, blah. And now more recently, you don't really care about that. But actually, traffic has increased folds upon each other. And often what you may see is that you'll have different experiences on like the web page. They might put a gate in front of it. And then once your item is in the cart, that's a different experience as well. So you want to be able to break those apart so you can scale each individual part, you know, because one person, or let's say 1,000 people, might be refreshing pages nonstop to get a new Xbox, but there still might be another 5 million people, you know, like browsing the rest of the website. You want to make that a good experience. while, make sure they can get into the checkout and individually there too. So you want to break those little pieces apart. So if one thing goes down, it's not going to break everything for all of your users.
Exactly.
Yeah.
And that's exactly what microservices do. And so let's take a little bit of look on how we can use them.
Yeah.
And everything else and all the great things about microservices. And so, like we talked about a little bit before, James, on how they're spread out. Each thing is a little application, essentially, and they are scalable. They're highly available. You can also deploy them separately, which is really neat. Meaning that, James, your application, if you need to make any fixes or I need to make any fixes, we're not dependent on each other. We can just push them out. And what's neat, though, is that really they're driven by the cloud. Everything is cloud now. And so microservices kind of fit in this unique pattern, and that we can push them into what are known as containers. And these containers fit really nicely into the cloud, cloud native, you might have heard of before. And so these containers individual parts. So you have one container for one microservice, and then you can pop them up, scale them up, mini containers as you need, scale them back, or robustness, push them up. If one goes down, you can have another one come up automatically. We'll get into that a little bit. So yeah, that's what microservices are. Kind of like these little applications, each in their own container for what we'll talk about today. And yeah. And so one thing though, James, that when we're building up microservices though, is that you kind of have to follow a map, so to speak, and that you want to follow like an architecture, and kind of otherwise you'll get lost, right? You might not do it properly the same first way, So you kind of just want to follow an architecture, and so really when you're breaking up a large application into a set of smaller, there's a couple guiding points that you want to follow. And first one is that microservices, they should be small, they should be independent, and they should be loosely coupled. And this is kind of what we've been talking about over and over again. One fails, it's not going to have everything else fail. And they're super independent, which means in my scope, not only does they're not like one fails, the rest don't fail, but they are focused on one job, taking orders, serving order, or being able to check out and stuff like that. So, and they're loosely coupled, meaning obviously they're not, one fails, the other ones don't. So yeah, and microservices do one thing and they do it well. A next guiding point is that this is really neat. Each microservice, as we mentioned before, is going to have its own separate code base, which then means that it can be done by its own small development team. And what's neat here, James, is that you're super into video games. And so if we're going to be making a video game, let's say storefront, we're going to take over GameStop and become the next meme stock. You, James, can then take care of like inventory for video games, or like the reviews, stuff that you would know. I wouldn't, but I can take care of the backend, like the order processing. And so our small development teams can have expert knowledge in our domains, which is pretty neat when is way that goes. So each microservice has its own code base, and they're deployed independently. So loosely coupled, it kind of goes in there. So we need to scale up, or we need to fix something. I mean, that way we can actually shoot it out and not worry about breaking anybody else, because it's its own application. And then here's the thing that really got me when I first started learning about microservices, because it's so different than your monolithic applications. Each microservice is going to have its own database. So it doesn't mean, it's really hard for me to understand it coming from the monolithic, where we had 50 million projects in one solution and they all used the big same SQL server. On a microservice level, they're all going to have each individual database that serves the individual purpose of that microservice. So you almost have like micro databases going along with it. And you really don't want to share databases across microservices either, because they're so independent. By having a shared database, you're kind of coupling them together.
Yep. So you might have a reviews database that, and then a products database and then customers database. You're not going to shove them in with a bunch of different tables. Makes sense.
Right.
Gotcha.
Exactly. Exactly. And kind of going along with that is that the microservices themselves, they're going to communicate with a well defined API, meaning that one microservice, it does not care how another microservice implements its code inside, as long as it defines its API. That way, you know what surface area looks like, what parameters are taking in, what the function is going to return. Microservice B could not care how microservice A implements its logic.
Hmm.
It could be hitting a file for its database as far as microservice B goes, as long as microservice A takes in the same parameters and returns the same, like a string for its function. As long as it does that, microservice B is happy. So API surface is all the microservices care about. They don't care how things are done internally, which makes sense when you think about it. And that helps different teams be able to use different microservices. We're all getting to this small, independent, loosely coupled over and over again. And it also then, again, small, independent, loosely coupled, supports polyglot programming. What that means then is if you want to write your stuff, James, in, let's say, Python, I could be writing my stuff in Ruby, or we could be doing it in .NET. But the point is, it doesn't matter what language you're using,
Yeah.
as long as that API surface stays the same.
Yeah. When you think about it, right, that's kind of the nice thing, especially if you come into an existing application, you might be adding a new service in, and traditionally you'd be forced to use whatever technology stack that main application was, like in a monolithic application. When you break it apart, then in those instances, you can have each of the different microservices being able to be deployed in their own languages, their own technology. Do we have more bullet points here? We got a few questions.
No, that's the end of the
Okay.
bullet points. Yeah, so let's hear them.
Yep. Okay. So Ali was asking, is there any frameworks for .NET that cover like API gateways, event buses? I think it's like things coming together. The thing that I would say is you could look at YARP, which is YARP, which is yet another reverse proxy for doing API gateways, or probably Dapper, DAPR, is a great one that sort of bridges stuff together. It's sort of an advanced topic, but let me know if you want more specifics or things like that. You can follow up with me and Matt after. And then Handy was asking, can microservices only communicate with each other over APIs?
Oh, you mean like, so microservice A, our order microservice, talks to microservice B, our menu microservice, or APIs. So I guess, what other way would we be talking? I guess my answer to that is yes. Or are we going to be talking like messages?
Yeah, it could be
So
pub sub, right? I
yeah,
guess you could have input and output bindings, event
right,
driven.
right.
A good example of we'll talk about this application later. We did one which was we had a microservice, we had a web API microservice that took in a request, put some information on a queue, and then we had another microservice that was listening to that queue to process the queue, right?
Right.
And the reason we split them into two different services is we didn't want the API to get bogged down with a long running process, for example.
Hmm.
Yeah.
But at the same time, you're still kind of respecting what the API or the input and output of that microservice is going to look like
Yeah.
when you put it onto the queue. So even though you might be using like even event grid or something like that, you still have to know what to send in order for that microservice that's listening to it to be able to pull it in.
Yep.
So kind of.
Yeah. Kind of.
Yeah.
Steve was asking, we were talking about databases and reviews. He asked if a reviews database would store a product ID from the product's database. Probably. I mean, it needs to know about each other. So yeah.
Yeah.
Because probably what you do is when you would submit the review to the API, right, it would send some metadata about what the review is for. Then you'd store that information.
Yeah. So what you might not do is store the internal primary key. So
Mhm.
like there might be an internal primary key and an external primary key possibly.
Correct. Yeah.
That way.
Yeah. That would make sense. Yeah. And that way, for example, you don't, in case you have to change the database and that key changes or whatever. Totally.
Right.
Yeah. Let's push forward.
All right. On and on. So why develop with a microservice architecture. And I think, James, we've
There's
been
all the
kind of
things we just said.
hammering it over and over again. But really, so what we're really doing is we're encapsulating as we over on the right hand side here, James. Each of those little hexagons are microservices,
Yeah.
and you can see on the gray boxes right down below, those are meant to signify applications. So each one of those microservices can go into different applications all up. Those are logical applications, kind of think of them as, and they can be independently scaled. They can make sense elsewhere. So, like if you have a Contoso pizza, it's delivering its menu. It can deliver its menu to a couple different ways. Like you could have an in-store menu,
Mhm.
like sitting on an iPad. You can have the menu being served over the web as well. So these microservices can span many different things, and they can be scaled up, scaled down, and yeah, and everything else we talked about as well. So
Totally.
yeah. So now let's talk about containers. All right. So we have the microservices, right? But what do, logically we have them in our head. We know how we're going to code them up. They're tiny, they're independent, they're loosely coupled. But really, kind of like how do we deploy them? How do we package them and get them out there? So containers are a great way to do this, right? So it's like an approach. It's it's a software development approach, really. And so what a container does, it puts your microservice, the code that you write, together with all of its dependencies. Like, so we're talking like the .NET runtime, like so ASP.NET,
Mhm.
ASP Core.NET, or ASP.NET Core, all together into this one self-contained package or container.
Yep.
And then you could take that container and pop it onto an overall operating system or virtual machine. And then when a container needs more, like it's Black Friday and you're scaling up, you can make more and more containers be available at one time. So that kind of takes care of how you would scale things. So the container is like this individual unit that's just one microservice.
Yeah. You can
Yeah.
think of it as like normally if you right click publish and you just publish in general, right? Just traditional route, which again, there's nothing wrong in microservices may make sense for your application or maybe not. It all depends on what you're building. But when you think about even architecture, maybe you don't containerize everything, but it might be a nice way of just architecting your code. But the nice thing is that when you containerize an application, it does contain everything, like you said, Matt, right? So it has everything that needs to run on it. And there just needs to be this host basically that is able to run
Yeah.
the container, which means traditionally when you would right click publish, that infrastructure, the host needs to know often about what you need to run the application. This is the reverse, which is you are bundling all the requirements together into a self-contained package and delivering
Yeah.
it to the host to just run and execute the container.
Right. And so what's neat about that then is that if I have that container and it works in my Docker host, let's say, and you have Docker host, my container is going to run on your Docker host. So like it's going to work. It like kind of gets rid of the, well, it works on my machine
Mm-hmm.
issue, which
Totally.
is really cool.
Yep.
But as the note says over here in the lower right hand corner, you don't need to containerize an application in order to call it a microservice. There's many other ways, like you were saying, James, like to right click publish and then like publish it out to Azure App Service or like even virtual machines. There's many different ways to do it. We're happen to be talking about containers here. I personally feel doing it with containers is a nice, easy way to do it and a way to understand it really easily. But there's many different ways to do it. So, all right.
Totally. Yeah, I think that's a good way of looking at it too, because when you think about it, yeah, like, yes, technically we could have like 10 APIs and those APIs could all be deployed and be scaled up with app service independently. And that's
Mhm.
another route to go, especially if you're comfortable with it. So there is an architecture mind frame, and then there is a like tooling and infrastructure addition that you
Right.
can add on to it with tools like Docker.
Like Docker. Now, Docker itself, we were kind of talking about the host before. And so
Mhm.
Docker kind of plays as his host, right?
Yeah.
Now, Docker is two different things. So there's the Docker project, it's an open source project. And then there's the Docker company.
Yes.
And so the Docker company kind of helps steward the open source project. And the
Correct.
Docker company, what's cool, the Docker company like partners with Microsoft to like kind of help Microsoft, us, like have Azure being really tuned up for the Docker project to be able to work nicely. And it also helps us, like if we create an ASP.NET Core image, which we'll talk about in a second, by working with the Docker company, we can kind of make sure everything works really cool. And it's, yeah. So it's a Docker project, which actually runs the images, which we'll talk about in a second, runs the containers, and then you have the Docker company.
Yep.
And so what's neat is Docker containers, the project, they can run anywhere. You can run them in Azure Cloud. You can run them on premise. It's just really an executable that is running.
That's a good way of looking at it. Totally. Yeah. So it's always a little bit tricky when there's a, company behind a product as well. We had that with the Xamarin days, Xamarin of the product, Xamarin the company.
Yeah.
But you get it. Yeah. There is this open source project. And we'll talk about a lot more as we go forward, because I think we'll talk about a lot of the terminologies. I think sometimes nailing down the terminology is what kind of confused me in the beginning. But once you kind of get some of that key terminology down, then you'll kind of understand what you're coding against every day.
Yep. And that's the hard part. And so let's get into the terminology.
Yes.
All right. All right. So the first one is an image. Okay. So we're going to be using, let's say we decided we're going to use containers and we're going to put them on Docker. All right. So we've decided we're using microservices. That's our architecture. And now we're going to implement them using Docker.
Yep.
All right. So the first thing we're going to come across now is an image. So the image is everything that we're going to put together. It's going to be like our runtime, which would be like ASP.NET. It's going to be our code that sits on it. And so it's this way that we can define everything and have it together. It's like our definition of everything together. And then when the image actually runs within Docker, it becomes a container.
Yeah.
So the image is a statically represented file, essentially. And it's that image that I can pass around to people and know that if it runs in my Docker runtime, it's going to run in your Docker host as well.
Totally. Yes.
So,
and then also, like, remember when you look at this stuff, like images, an image would be like, you can get the ASP.NET Core image right from us and use it in your application. And then you can containerize and put it anywhere. And of course, we'll talk about containers where you deploy them. And of course, there's different services that host. Docker is one of them. Azure is one of them. There's other ones out there. And there's obviously costs associated with hosting and running containers wherever you're at. But to use the core Docker experience locally, which we'll show off, everything like that, that's not going to cost you anything.
No, not at all.
Bandwidth, I guess.
Bandwidth. Right.
Yes.
There's always bandwidth.
Images. It contains the stuff to turn into a container.
Right. So an image is the more or less the static portion of it.
Yeah.
And so how you create an image is from a Docker file. So the Docker file, it's kind of more or less a scripting language, and it contains instructions of how to create a Docker image. And so just kind of going through here is like that from line, the very first part of it, that MCR, Microsoft.com, that actually is an image that Microsoft created. That's the .NET 6.0 SDK.
Yeah.
All right. And then that work there, that's saying, all right, in my Docker image, switch over to the source directory. And then we're going to copy our backend proj file and actually run .NET and then eventually publish .NET. So that first one is saying, all right, first line up there, that from again, our base image is .NET 6.0, which Microsoft created. And the rest are like lines to actually go through and create our code based on our project from it. And we'll run over this again, but really a Docker file is just a text file to create a Docker image. And we generally start from an image that somebody else created for us.
Yeah. And of course, you can create your own image if you desire. The other thing, too, that's really nice about this, there is really nice tooling into both the Visual Studio and Visual Studio Code that will generate these Docker files for you. There's a lot of reference material, too.
Yes. All right. So we'll do a little video here, James. This won't take very long to kind of explain how everything's working.
Cool.
So over on the left-hand side, that's our client host. All right. So once I start playing this, and what we have here is client the Docker host, which lives on a client, and then their Docker registry. And what's interesting, you can put images up on a Docker registry, which is kind of like NuGet for Docker images. So you can say, all right, let's go get an image from the Docker registry, pulls it down, and then I can create many different containers from that image. So to kind of rebuild that is that on our client, we have that Docker host on our client. We say, all right, I want to go get for my NuGet of Docker images, which is Docker Hub, bring that down, bring an image down. And from that image, the purple one, the top one, I'll just say, because the colors are kind of close together. From that very top image, I want to create a new image based on that. And from that new image, create a container, which is really just the image running in memory.
Yep.
Make sense?
Makes sense to me.
All right. Very good. So now we're here, James. Why would I want to build microservices in .NET other than the fact that .NET's the best framework? That's platform. We'll call it a platform. I'm going off on a tangent. Other than .NET's the best platform in the world. Why?
Because it's built to be cloud native first.
Yes.
Performance. I don't know. Performance, size,
Yep.
use C# everywhere, do all the things.
Yep. All the things. Yeah. And so you mentioned built to be cloud native first. And so what's neat about that, because way back when we had .NET Framework, it was Windows only, right? And so then we iterated into the whole .NET Core world, which was one of the main things about that was that .NET would run anywhere, which you mentioned. So that anywhere includes not just Windows, not just Mac, but like flavors of Linux as well. Yeah. And so what's neat is that the Docker container and the images, which you were just talking about, those could be various flavors of Linux. So now we have .NET that can run in its various flavor of Linux, which is super cool. And .NET is cloud native first, which means that Kestrel web server and .NET is extremely fast. So that's neat. And so now we have this .NET that runs anywhere, Kestrel super fast. And yeah, so why not build a microservice in .NET? It's fast. It runs everywhere. C# and all the things. I think you should. That's just me, though.
And you can build all the things with it, right? You can build APIs, you can build websites, you can build, you can talk to databases, you can build all sorts of stuff, real-time communication with it. So I think that's the nice thing too.
Yeah, you have the full power of .NET, and you have the full power of NuGet as well, like to get all your libraries that you wanted to reuse. I mean, so you can be reusing all your code inside a Docker or inside a container. Yeah, I mean, it's just when you think about it, it's mind blowing how powerful it is. And so here we are. All right, James, we kind of hit the first part of the session, so we should probably do a knowledge check, huh?
Knowledge check.
Nice. We should ask Rob behind the scenes if he can come up with some knowledge check music for us.
Check. Can just clip that.
All right. All right. There we go. The first question. You want to take this, James, and I'll see if I can come up with the answer.
Sure. You can also answer in the chat wherever you're at. If you know the answer, but ABCD, which of the following scenarios would be a candidate to become a microservice? A would be a web API that returns a list of pizza. B would be a web API and a website that return and display a list of pizzas. C, GitHub actions used to deploy a website. Or D, a Docker image.
All right. So let's think about this one. A web API that returns a list of pizzas. That kind of sounds pretty close to what we're looking for, huh?
Yeah.
It's pretty single purpose.
We talked about that quite a bit.
Nice. Yeah. I'm pretty sure that's going to be it. So web API and website, that's kind of, you're pushing two different functionalities together. So I think we can eliminate B.
Yeah, only because this would be like to become a single microservice is kind of what it's saying here.
Yeah, a single microservice. So I think B is going to be two microservices, really. You got the web API and then you have the website.
Yeah.
GitHub Actions, that has really nothing to do here with a microservice. You can use it to deploy it. And a Docker image itself is not a microservice, but rather a means to deploy the microservice, so to speak.
So I'm going to go with A myself.
Yeah.
We also happen to
Boom.
write. You happen to write these, so I guess you win.
Yeah, I shouldn't be. All right. So question 2.
Oh,
So go ahead, James. You
yeah.
can.
What purpose does a Docker image have in a microservice architecture pattern? Would it be a text file with instructions on how to build the microservice? A Docker image is a static representation of a microservice's configuration and its dependencies, or Docker images allow hosts to perform load balancing and routing.
All right. So A sounds to me like it's a Docker file, right? It's that has the instructions to build the image, is what A does.
Yes, that sounds about correct. Yes.
Yep. And then B is going to sound to me like it's the right answer. And I'm not just saying that because I wrote the question and the answers. But
I'm gonna
B
go with
really
B.
is the image is a static representation, and the configuration and all its dependencies packed together, and it's like it's the loosely coupled unit of work that we can deploy. And C, the Docker images that allow hosts to perform load balancing and routing. We'll talk about what those are in a little bit.
So
So
we didn't even get there yet.
yeah, no, that's a little foreshadowing.
Yeah.
So yeah, B is the right answer.
Cool.
For question 2.
Oh, more questions. Why would a developer write a Docker file? Great question. We just talked about it 5 seconds ago. To create the initialization routine for the Docker engine, to create a text file with instructions on how to build a Docker image, or to create the code that run in a microservices. And everyone is chiming in with B because we just talked about it and is totally it. Yes, it is.
That's it.
And
Yep.
how to build the Docker image, which uses Docker image, from the registry.
Yep. Perfect. Next. All right.
Okay. I thought we had more questions. I was like,
oh, no.
Let's write some code. I'm ready.
Let's write some code. All right. We are going to build a Docker file. We're going to go clone the code. We're going to build the Docker file, and we're going to show off to the web API from the back end.
Let's do it. We're literally going to make pizza happen. I'm going to eat pizza tonight. No, I'm going to make burrito bowls.
Burrito bowls. All right. Yes. Well, let's rewrite the learn module. We're talking about burrito bowls.
I'm glad that you rated this module too, by the way.
I know. You know what? I don't have to. We're doing pretty good on here. I could have not rated it, but you have to get the ball rolling. Somehow.
This is the module, so we're going to do it.
This is the module. All right. So what I'm going to do, we've already gone through introduction and what our microservice is, but now we're going to go through and build a microservice or build a Docker file for your microservice.
Yeah, we're not going to show you how to build the actual web API, because the cool thing is that you can turn any web API into a microservice. So we're going to pull down the code, take a look at it. If you didn't get to watch the earlier Learn Live sessions, specifically with a bunch of amazing individuals, you can go back and watch the episodes and we'll watch them later. What are you doing? Why are you writing stuff? What's happening here?
All right. So what I'm doing, I'm just changing directories into my desktop. Okay. That way I can clone it down.
Okay. So we're going to clone some code.
Right now, git clone. Going through here just kind of tells me open a command prompt, change to the directory. I'm a rule follower, James, so that's exactly what I did. And then now all I'm going to do is this right here, clone the file or clone the repo.
Now
git clone.
I'm going to say prerequisites here. Like we're using VS Code today. You could do this in VS. Other IDEs, you could do it right at the command line, directly wherever you're at in terminal, whatever you want to do. And all we have installed right now is GitHub, Git, and also VS Code, and of course .NET 6 also required to run this pup.
Right.
And so you cloned it, which means you got the code and you put it on your machine. You cloned it.
Yep. And so
a copy. It's you didn't move it.
I didn't move it. All I did was go and get it. And so here it is.
Oh my goodness.
Yeah.
And so all those things.
Yep, we got a back end, we got a front end, and we got like the Docker ignore file and blah, 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 but we're not going to worry about that quite yet. Okay. But what I'm going to do is just go into this back end, and you can see we actually have this pizza info controller.
So this is an ASP.NET Core web API controller. We talked about this. Now, this isn't a minimal API, but it would also work with minimal APIs because they can work together. But what this is doing is this is going to have a list of pizzas. And I'm looking here. It looks like there's a single get, which is the menu at /pizza info.
Yes. And so let's let's just go like this. Where am I? Let's just do backend
Okay.
and do .NET build.
So what we've done right now is that you navigated into the web API backend,
Yep.
and then you did .NET Build, which builds the application. Now, this doesn't
Yep.
require any containers, Docker stuff, anything like
Oh,
this. All you're
so
doing is just building it with .NET built right in.
yeah, just building it and running it with .NET. This way we can show everybody what the application looks like.
Mhm.
5901. Ooh, we'll use
Gmail.
Swagger. So it has a Swagger backend already built in because this is just a file new .NET, and we said to use Swagger, and this is just what it looks like. So we'll try it out. We'll use the get, and this is what we're getting. So yeah, pretty simple. Just returns a bunch of JSON with a pizza, how much it costs, the ingredients, and whether it's in stock or not. Nothing special or fancy happening.
Perfect.
All right.
So,
So
so
let's
we
build
did
up
get
a
a
Docker file.
so we did get a question here really quick
Yep.
before we go on from James. Is James is asking, is really all microservices is a web API? What's the difference?
From a web API to a microservice?
Yeah, is asking specifically, what is the difference between was it is a microservice only a web API?
Well, it can be more than just a web API. It could actually be a web front end too, because you can see right here, we're going to build up a front end as well. Like right here, this is actually going to be something that pulls back the pizzas and displays them. So that could be a microservice. So a web API is a great microservice as long as it's just doing one thing. So our pizza info is just pulling back information about pizzas. So a lot of times a web API is going to be a microservice as long as it's really focused on doing one thing and one thing only.
Gotcha.
So
So in this case, this backend for James's question here is this is a sort of microservice. It's a web API that's only getting the pizza information. It's
right,
not also the ordering system and the website, right? You could put those all into one, but they're broken into multiple projects here.
correct.
And additionally, like Matt said, you could have other things like the front end, but additionally, you could have other types of services, such as worker services, is another good example of long running processes. And again, that could be in a different project. So you can put
Mhm.
different types of things into microservices.
Correct.
Yeah.
All right. So let's get back. We showed the it running just in regular .NET. So let's create the Docker file for the back end. And so I'm just going to copy this over. We kind of took a look at this part before, James, right in the slides.
Mhm.
And so when you build up a Docker file, you're going to use a file called dockerfile. There's no extension to it or anything like that. It's just called dockerfile. And in VS Code, you can see it kind of gives it that nice little Docker icon.
Mhm.
But I'll pop this in here now. Now it says, as we went through before, it's just saying from the .NET SDK 6.0 base image. And then it's saying, all right, within that base image, switch to the SRC, or what I'll just call source directory, and then copy my local backend CS proj file in there to just the dot. So what it amounts to source. And then run .NET restore. So grabbing all the NuGets, and then copy everything else, all the other source files like pizza info, program CS to source, and then run .NET publish using the configuration, the release configuration, and output that to an app directory within the image. So that kind of makes sense enough for now. So it's just kind of giving a build instructions on what we're doing here. And then we can go down, and then there's another one. So we just built it, right?
Okay.
All we did was built the web API and published it. So next thing, we actually going to want to run it. And so here, our base image is the ASPNET 6.0. And what I'm doing then is I'm changing my working directory over to the app working directory, exposing some ports 80 and 443. And then this is neat. I'm saying you could see all my IntelliSense kind of popping up too, kind of giving me some help. That's the tooling from VS Code.
Yep.
But my copy right here, I'm saying -- from equals build. Right here, that's from the top. That's from my build image. I'm saying take everything from build in the app directory and just pop it to the local working directory. And then all I'm saying is my entry point, just do .NET backend DLL. So essentially, we're just going to run the app then.
Okay, so this Dockerfile is doing multiple things, and then
Yes.
is this what happens when it starts up? For all intents?
This is what happens when it creates the container.
Got it.
So all this together, when I run this, I'm going to create the image from this, right? And then when I run it, when I create the container, this right here, the entry point, so the container is the in-memory representation of the image.
Yep.
If that makes sense. So once I started up the entry point where where the container work hits everything, the main the main function, you can think of this as the main function is .NET, and we're just hitting the backend DLL.
Got it. Also, a good question in the chat is, what is ASP.NET Core?
What is ASP.NET Core?
Yeah.
Oh, that's a great question. That is our runtime for essentially web applications. So it is based off of .NET, and it's a kind of like how Xamarin is the runtime for mobile apps. ASP.NET is the runtime for web applications, and you could be building full featured like Razor apps. You can be building, is web forms even a thing anymore? I don't know.
Totally.
But you could be building web APIs. You can be building front ends with it. It's .NET's version of the web.
Yeah. Yeah. No matter what you want to build in the web, whether it is, like you said, a website, an API, a real-time application, there's all these different services to do that. And part of what we're doing here is we're building a web API with ASP.NET Core. And we'll specifically, Rob will put a link to our .NET website, and you can click on web right there. It's dot.net.
Perfect.
Yeah.
All right. So let's get to building the actual Docker image. So to do that, I am going to actually do clear. Did I type that right? Oh, actually, let me actually stop, and then I'll type clear. All right, here we go. And then it's going to be this, which is kind of, my font's a little bit bigger, but it says Docker build. This -T is giving it a tag. So essentially, I'm giving my image a name, and I'm calling it Pizza Backend. And because I'm in the backend directory, I'm just saying look for a Docker file in the current directory with that period. All right. So let's do this. And now it's going to go out and it's going to grab everything. So it's going out and it's grabbing the .NET 6 SDK and building it. It's going to go out and grab the ASP.NET image. And the first time it runs, it takes a little bit to go and get everything, but it's doing it.
Yep. Good question coming in while this is happening too, from James, very active in the chat, which we love. So let's say you had 3 APIs. You had a Docker file for each of them, creating images for each of them. Well, a Docker image for them and putting them in their own container. These would be small services, is what he wrote. Then I would call these APIs via a Blazor app. The 3 APIs would be microservices?
Yes. The 3 APIs would be microservices, assuming they only do one thing.
Yeah.
They're really narrowly focused.
Because then you could take any of those and you could scale each of those independent APIs up or down and swap them out. And a way of configuring that might be putting in, URLs into like your Blazor apps, like configuration, basically, because those APIs are going to live in different places.
Yep.
Yeah.
So cool. And then we're going to actually talk about in a little bit, James, how we can actually control building multiple microservices in multiple Docker files and keep it all within control. Because as you can imagine, having multiple Docker files and trying to do everything at once can get a little bit unwieldy. But anyways, let's continue on what we're doing right now.
Let's do it.
So we have everything built. And if you go through the output, you can kind of see stage 1 of 3. We got the ASP.NET, a bunch of SHA-256 signatures, blah, blah, blah. But all the way down to the file, it says, we're good. So let's actually prove that we're good and go to the Docker desktop. And that's where I have everything running. So I had to actually go and download Docker desktop beforehand. And here it is. This is my pizza backend. And it's in the images portion of Docker desktop. It is not in the containers yet. So an image is only is the image.
Yep.
A container is the in-memory representation of that image. So I'm not running it yet.
Okay.
The pizza backend is not, I can't browse to it yet, but it's there. And I could share this pizza backend with you and it would work. Actually, all I have to do is share this Docker file with you and you could build it up and run it on your own Docker host. But we're almost there. So here it is.
Cool.
So let's run it. And that's what this next part shows us. We can do Docker run. And I'll talk about it right here while we can just see it. So what Docker run does is just saying doing an interactive mode. And so when we run Docker, this is the most interesting part. This -p means ports.
Okay.
And so internally, Docker has its own network inside itself, which is running, which is amazing. So it has its own network that is running. So internally, it's going to be running our web API on port 80 inside the Docker host. But we're going to have that exposed on port 5200. Okay, so what we're going to say is map port 80 internally so I can access it on port 5200.
Cool.
So, and then we're going to say, give it a name. We're going to call pizza backend the tag of the image. We're going to call that the running portion of it. We're going to just say it's called pizza backend container. Makes sense.
Love it.
Let's go back to this. I will CLEAR, bring it back to the top of the screen, paste that in, run it. Going to go through.
This is running the image in a container.
This is taking the image, and you can see right here, images is now saying in use. And there's my container running.
Got it.
Port 5200.
Got it.
So now if I would just go like this, HTTP 5200, boom, I got it again. And if I just do pizza info, there's just the plain old JSON edit returns.
Very cool. You want to know a secret?
What's that?
Go into your Docker desktop.
All right.
And then hover over that right there. Hit that. See that first one? Nope. Hover over, go to the right. Yep.
To the right.
To the right, to the right, to the right, to the right. First circle, open in browser. Yeah. So obviously nothing is running there, but now you could go to your pizza info or whatever. Yeah.
Boom. How about that?
There you go. And you can also, inside of here, here's what's really cool. Go to your Docker desktop, hover over that, and then go to the second circle.
Yes.
That's the CLI.
Yep. Come on. Yes. Allow. Here we are. Yes. And so now we are inside our container.
You're in it.
Which we could do stuff like so we do ls. We can see this is actually the website running. So you can see our API or our DLLs here running. So
pretty cool.
Super neat.
Yeah.
Close it. Yeah. And what also is neat here, we can shut it down. I can go to the images. And I believe we can see how when it went through and started things up, I can see everything it ran. So if I need to debug, I can see what hit, what went wrong, stuff like that.
Perfect.
Cool. All right. So we did it. We built up our pizza backend, popped it in an image, started it up. It's a container. We browse to it. It's returning our pizza. We're almost there. Kind of. Cool. We're almost there. Yeah. We got it running. We got it in the backend. So we just need to put our front end into a container. or actually an image, run it till we get a container, and we have our whole application microservice and up and running. But let's go back to the slides real quick. What we want to make sure we do is, as I alluded to before, as James kind of brought up from our questions, is if you have a bunch of different microservices running, it could get kind of unwieldy. Because if you think about it, if you had, let's say, you have the web UI, and then you have the menu, and you had one that was taking orders, and you have their own, each has their own Docker file. And within those Docker files, you can specify also like, or you also want to specify like what happens if one goes down, or if you want to be able to specify how they communicate with each other. Like you want to have the web UI know how to communicate to the menu and the order one, right? You want to have it know what the internal network address is within the Docker host, right? And then there's to be able to scale up. So you want one to be able to scale to 10x underneath certain certain load constraints. I mean, so there's all of this other, I'm going to say overhead, administrative overhead that goes along with microservices, and it can get overwhelming quickly. But that's where orchestration comes in. So here's a quick, I guess, image of what orchestration is doing. And so really the point of this here is right at the bottom is that the diagram is showing really, again, the 6 Docker images deployed as 2 different applications and deployed across several different clusters. I mean, we didn't even start talking about clusters. And so Docker images, really, you can think of it as a unit of deployment, right? We deployed our menu. We're going to deploy our website. We can deploy an order portion of it. And then the orchestrator takes care of all of that for us. Like, okay, it's going to take care of the deploying for us. It's going to take care of the scaling for us. It's going to take care of resiliency for us, all of that good stuff. Yeah. So it essentially is orchestrating everything together. So when you get to a lot of your production level stuff where you're going to have many, many different microservices, an orchestrator is going to come in indispensable when it gets to that.
Yep.
So why would you use an orchestrator? I guess we probably covered that a little bit about it though, but it helps when you compose a bunch of different microservices together to make a application. So I guess that's where orchestrator actually came from, because you're composing different microservices into an application. All right. And so Docker itself has kind of a built-in orchestrator. It's called Docker Compose. And there's other orchestrators out there. The best known one probably is Kubernetes. Kubernetes itself is a whole subject. It's big time. And so we're not going to be using Kubernetes for this module. We're just going to be using Docker Compose. But we do have a Learn module on Kubernetes. We have several, actually. And towards the end of this one, James, we'll talk about where everybody can go to learn more about Kubernetes, including a couple other Learn Lives coming up.
Cool.
So, yeah. So, what's also neat about Docker Compose is that when we build up the Docker Compose files, we're going to be using a language called YAML, which is what does it YAML stand for? Yet another markup language? Is that what it stands for?
I think so. I think it's controversy over what exactly YAML stands for, but
yeah.
Yes.
But it has a lot of tabs. You have to line everything up just exactly right. But Visual Studio and VS Code provide help with it as well. So
cool.
All right. So let's do a little knowledge check to just talk a little bit about orchestrators before we jump into it.
Cool.
Here.
I'm ready.
All right.
Here we go. Okay. So question 4, what is the use for an orchestrator? One would be to scale out and manage complex distributed systems of microservices. B would be to hold Docker images in source control, or C, which to automate security penetration testing.
Well,
some of this stuff, nothing to do with that, you think?
I know. It's going to be A, James. It's going to be A because, yeah, it's just exactly what we were talking about. I mean, it has orchestrator helps you compose many different microservices into one overall distributed application.
Totally.
Nothing to do with automating penetration testing. I think we were just looking to put something in there at that point. And you don't put Docker images in source control with an orchestrator. That's not the point of an orchestrator. Orchestrator is for more the runtime of getting everything up and going.
Cool. Oh, which language is a Docker compose file written in? C#, YAML, or JSON?
Well, we made a big deal about that just at the end. So
YAML.
YAML, whatever it stands for. But there we go. YAML.
Yelling at me language.
I never heard that one before. Nice.
I just came up
All
with
right. All right. So here we go. Creating a Docker compose file. So that's what we're going to do. We're going to go and create the Docker compose file. We're going to get the front end into its own Docker file. We're going to create the front end's image, and we're going to deploy both the back end and the front end using the Docker compose file. So,
Gotcha.
Sound like a plan? Let's do it.
Sounds like a plan, because the actual front end needs to be able to speak to the back end, but they're each going to be their own microservice, correct?
Correct.
Yeah,
Correct.
got it. Cool.
All right. So here again is the Docker file from the backend.
Yep.
Doing the same thing it's always did. Super happy we know it works. So we'll jump into the front end. And so the front end's just this plain old happy ASPNET Razor page application. It does what you would expect a Razor page application does. Here's just how it creates thing. The main does a startup. Nothing fancy here. It's just really its base. Away we go. And then in the pages, index, we're just going to go loop through and we show our pizzas together in a table. Super easy. And right here, we just say, get me my pizzas.
Okay.
Nothing fancy in there. One thing I do want to call out though, is that when we new up this HTTP client, we do have to get a backend URL out of there, which is here. And right now it's localhost 5901, which when we're developing locally is what our backend ran at.
Got it.
Got it. So that's going to come important. Just remember backend URL is our configuration.
Okay.
Name, keys name. All right. So not Docker ignore that Docker ignore file. The Docker file here, this is for the front end. And so we already built it up. There's really not much difference between this front end Docker file and the back end one, except we're just using the front end.cs proj, doing the .NET restore, copying it, and then using the release configuration. And then again, using ASP.NET image, building it, and then using the entry point of .NET and saying use the front end.dll here. So really exactly the same Docker file, except we're using the front end.cs proj file here. So nothing really has changed at all. However, we want to compose the front end and the back end together, deploy them at once. And that's where this Docker compose YAML file comes in. So let's start playing with it. I'm going to go back to our exercises. And I'm going to create a Docker compose file. All right. And so I'm just going to copy in this. And here we go. So I'll explain what's going on. And so we're just going to use version 3.4. That's just some boilerplate of what we need. And then here it's I'm going to create some services. And I'm going to use one that's called front end and another that's called back end. Okay. And so it's saying here, I'm going to use an image called pizza front end image when I do this. And it's saying in my context, my front end context, which happens to be this front end directory, use the Dockerfile and then build it up. And it's going to depend on this backend image first being there. Okay. So it's going to use the backend Docker image in the backend directory. Dockerfile is called Dockerfile. So let's break this down again. All right. So when we go through, it's going to create two services for us. First one, we do backend. And when we build it in the context of backend, which really is just the directory name, it's going to look for a Docker file called Dockerfile. When it builds it, it's going to map out port 80 to port 5900 using the pizza backend image. Okay. Then front end, because it depends on backend here, it's going to pretty much do the same thing, but in this environment, that's where it's cool. It's saying, all right, backend URL, it's reliant upon just HTTP:/backend, which happens to be my backend service. So that's all I need to do to specify the internet address, essentially, of where backend is running, just by calling it the service name.
Gotcha.
Yeah. And then here we're just specifying what ports are running, both running 80 internally. One's going to be running on 5900 externally, the other one on 5902.
Cool.
All right. So that's pretty much it. And so what I'm going to do real quick is go to Docker and shut that guy down. I'm just going to remove it all together. Nothing's running. It's still here as an image, but it's not there as a container, as my backend. This way I can build them both up.
Okay.
All right. So next step. What we're going to do is do Docker compose. So I'm going to open this back up, do a clear, and do docker-compose. Actually, what I really want to do is cd docker compose build. And all I did was to move back up so I can see the Docker compose file. Before I was in the backend directory, so I moved up one directory.
Got it.
So I'm just saying docker compose build. And so it's going to actually build up the images from the Docker files for me. So let's run that.
So it looks like this got through a lot of those pieces a lot faster.
Yes.
Because you had already downloaded them, correct?
Right. So that I didn't change pizza backend at all. So I was able to just use that and go. So if I do Docker images here and hit enter, you can see I have pizza backend was done 19 minutes ago.
Got it.
But pizza front end is from 14 seconds ago. So because pizza backend didn't change, it was able just to use that one and not have to rebuild it, where it just had to rebuild pizza front end, which is pretty neat. All right. And then to actually start running everything, all we have to do is do Docker compose up. I'm going to clear this out again, do that. Now, what we're doing is that we're just starting everything. So I'm going to jump out to here, and we should see mslearn.net microservices. That's the name of my whole Docker. It's actually the name of the directory of which the Docker compose file is running in. And you can see now it's orchestrating. It's orchestrating both the back end and the front end. So I'm going to try this, James. Okay. Open in browser. What's going on?
What's the back end?
Is that the back end? It was the back end. Thank you. What's going on? Let's eat some pizza.
Nice.
And there we are. Yep.
So here's a good question for you, because somehow you kind of mentioned it here, but the front end knows how to speak to that back end. And James asked, how or does Docker magically know what URL the backend service is running in just by entering its service name?
Yes.
Yes.
Yes. Yep. It magically knows, because when we go back to here, we're saying this backend is a service. So you can think of this as the DNS name, essentially.
Mm,
So this is like, montemagno.com,
yeah,
essentially, for backend. And so that way we just have to refer to it as backend.
got it. So it's going to
So
basically
it's
take the output and kind of map it over there.
yeah, it's the DNS name
Got
for
it.
all intents and purposes.
Got it. Okay. There you go.
Yep. And there we have it.
Cool. You did it. We
Yeah.
did it. Wow.
We did it. We Docker composed it. We have orchestrators running. We have Docker files running. We have images somewhere. We have containers places. What more could he ask for?
I know. More questions to be answered.
Yeah.
I actually don't know if there's any more questions.
You know what though, James? I wanted to show you something real quick. You know
Yeah.
how you before showed how you can jump into the CLI?
Yeah.
So there's a couple different tools that you have within VS Code
Mm.
that there's a whole Docker extension there
Oh.
as well. And I can actually see the images here. I can see my pizza backend, my pizza front end that they're there. I can see the containers that I have up and running. I can even see, let me make this, they're not playing nicely, but I can see the files that are
Oh, cool.
within my containers too. So that's pretty neat.
Yeah.
And I could even, going way down here, it should have popped up, open a remote window. I can do open folder in a container.
Wow.
And stuff like that, or even attach to a container. Let's do attach to running container, and I'll do the pizza front end. And it opens up a brand new instance for me of the front end. So now I'm actually, once it actually attaches, we'll be actually running. And there we all go.
Oh, cool.
And yeah. So that's kind of neat. And see the app, that's where everything is. And there we go. And so I can look at the web config file and actually app settings.json. Development.json and look at that. It's actually localhost 5901 for our backend URL. So yeah, that's kind of
Nice.
neat, huh?
Yeah.
So yeah,
Cool.
just a little bit of something there that you can actually go in and mess things up if you wanted to. So
And the other thing too about the tooling is that, well, we showed in this learn module how to create things by hand. You copied and pasted. There actually is tooling inside of VS Code in VS 2022 and 2019 that you can sort of kind of almost right click and add a Docker file, add Docker Compose, and it'll scaffold out a bunch of stuff for you. But it's cool to know exactly what it's doing under the hood.
yeah, I think, you have to understand the basics, even if there are a basic example like this. That way, when you see the tooling do it, you have an idea of what it actually did.
Yeah.
So
There's a good question from Felix. What are the next steps after this as far as scaling them up? Well, I guess you'd have to deploy it somewhere.
Right. So what we would do normally is that we would go to like you would deploy this to their images to Azure Container Registry, and then you can actually spin up like Docker up on Azure like this. So the next steps would be to actually have, instead of running Docker desktop, where did it go? Instead of running Docker desktop, we'd be running Docker in Azure somewhere, ideally in Azure or in your own data center or wherever you want to run it. So we'd be running that somewhere, and then we can actually be scaling up our containers that way. Or if you want to go the orchestration route, you can be running Kubernetes places as well. And so what's neat, at least about the containers, is that you can actually deploy containers to things like App Service, Azure App Service as well. Have those out there. And so you can actually build up your whole image file and then deploy that to Azure App Service. You don't necessarily need the whole Docker host. It's there, but you don't need to do that yourself. Just deploy the image file and it works. Or you can actually run it, do it all from bare bones if you wanted to. But yeah, the next step would be, go ahead, James.
Oh, yeah, I was going to say another way. You mentioned a lot of names of Kubernetes and App Service, but another new service from Microsoft is called Azure Container Apps. And what that enables you to do is basically take these containers and sort of appify them in a way, but it is sort of serverless, event-driven microservices for your containers. So what that means is, based on what you're talking about scaling, Felix, is you need to decide what your scale is. Is that traffic here or there? Nice thing with container apps, unlike an app service, which you have to have on, is that it can scale up and also scale down to 0, which is also very nice. So if you have an event-driven microservice, like maybe something like a service worker or queue listener, you might want to have it off until it actually needs to turn on. So you can kind of look at these different technologies. Totally.
Tons of choices.
Lots of choices.
Yep. So let's well, James, we covered what microservices are, all the different technologies and terminologies and everything that were in there, how they related, and we built one up, right?
And there's more.
Yeah, there's more. There's so much more to it. And here is some of the more. Yeah, so follow this short link, learn -live -first #1 st microservices. Learn live first microservice. It'll bring you to a bunch of different couple learn modules, an ebook, a great video that Nish did that explains all of this. It's super well, slickly produced. So definitely recommend to check this out. It has an introduction to Kubernetes, more about diving a little bit more deeper into Docker containers themselves. Definitely worth checking out. We just scratched the surface here. We barely got into it. You can really learn a lot, and it really is going to help your development lifecycle out a lot, I think.
Totally.
And again, this is where Microservices ASP.NET Core on the AKA MS. So go check it out. Definitely would like it. And of course, James, you were involved with more than one of these, the whole modern web development with .NET 6.
Yeah, this is a great series. This is the final chapter in this series. You can go back and rewatch all of them. So some of you were asking early on about, hey, what is ASP.NET Core? What is all these other things? Go through this. Don't go away yet. We actually have a few more things to show you about a full in production service that we want to talk about too. But go back and rewatch this, from building a web app, an API, from all sorts of different things inside of building web apps with Blazor, all sorts of things, and now microservices. So all sorts of good stuff. And Matt, we have more coming soon.
Yeah, we sure do. Amazing. A whole deep dive, learn live, deep dive with Nish and Laurent on microservices and .NET and ASP.NET.
Yep.
So how many are there? 8, 9? A lot.
A lot.
So you will come out of this being a super, super expert.
Totally.
Starts right after the new year on January 11th, 1-11 or 11-1, however you do your dates. It doesn't matter. They're all ones. The best #1 learn live ever at 1 a.m. Pacific time. Wow.
Perfect.
All right, James, one more thing. You have something you want to show us.
Yeah, totally. So during .NET Conf, which is our big .NET conference every single year, during the keynote, we'll put a link to the source code right inside of here as well. We built a brand new .NET 6 application, a web front end, web backend, native desktop, and mobile applications, all powered by .NET 6, ASP.NET Core for the front end, Blazor for the front end as well, powerful backend services powered by ASP.NET Core. Some of them have additionally web APIs. There's different listeners and worker services, and a native desktop mobile app powered by .NET MAUI, our cross-platform UI for iOS, Android, Mac, and Windows. So what I wanted to do really quick is show everyone the source code, walk through some of the things that we learned today because we use Docker and Docker Compose, and then how to get it up and running on your local machine. How does that sound, Matt?
I would love it. This is so amazing, this whole thing. It's the real world using microservices.
So I'm going to go ahead and share my screen over here, and let's go ahead and have have them bring it up for me. If Rob could. Perfect. Here we go. Awesome. So I am on the .NET podcast. So github.com/Microsoft/.NET-podcast. And you can learn all about it. So here's that image that we just showed you. There's actually a live running version of it right here. So you can actually just take a look at it, hit sign in. You don't need to sign in, but here's the podcast application running live inside of some different deployments and using microservices. It talks about the architecture. So it talks a lot about container apps and app service and different databases. You can see we have multiple databases here, feed, queue worker, how the websites are talking to it, et cetera, et cetera. But there is this local deployment quick start. is here's what's really cool about this is that there is actually a bunch of services. So we have a podcast API, an ingestion service, an updater service. We also have two web apps. One is the actual a mobile app and also a SignalR listening hub that is sitting here too, which is really cool. So what we did is we created this Docker Compose file, and this is going to look pretty familiar, version 3.4. There is a podcast API, which has, a Docker file that we talked about. It depends on the database and storage. We have an updater worker. We have a database. The database is a microservice, just the database sitting there by itself. We have a listen together hub. We have an ingestion worker. We have the website, and we have Azure storage, which also is a microservice in its own regard. So it's just inside of there, which is cool. Now, if we look at one of these Docker files, let's say for the API, this should feel very familiar. It's a little bit longer, but we see that we have the ASP.NET base, the worker directory. We're exposing ports. This feels familiar here. We're copying the podcast API. This is using multiple projects over here. So it actually has some shared code between the different projects. So it's copying not only the main web API, but also shared code. And then it's doing a .NET restore, and then it's doing a build over here too. And then it does a publish. So that's kind of what it does. And then as we can see here, there's the entry point, podcast.api.dll. So it's a little bit longer, but you can see that you can do kind of many things here as well, which is cool. So we're kind of doing this here. And each of these services has a Docker file. So we see the Docker files here as well, which is cool. So what I'm going to do is I'm going to come back over here. I'm going to copy and I'm going to clone this repo locally. So I'm going to pull it up over here. And you can do this in the command line. I'm just going to do it in VS Code. And I'm going to say .NET podcast learn live here. That's going to clone the repo and everything that I just showed you. There we go. And actually, if we look in the Solution Explorer, what we'll see is that inside of here, there's actually, well, I can zoom in, so that there's 4 projects inside of here, a services, a .NET MAUI Blazor app, a .NET MAUI app, and a website. And inside of here, we have the same source code. So we have mobile, a mobile Blazor, services, and web. And what we can see here is we have a bunch of different services that we're all going to spin up. Cool. So now what I'm going to do is I'm going to actually go down over to my command line, and I want to show you a few things. Here's Docker Desktop. First, I want to show you that I have no containers. I have a bunch of images. I did run this earlier because it would take some time to download all the images that we needed. But I have no volumes, which are also other dependencies too, which I'll talk about here in a little bit. So we have this here, no containers up and running. So all I'm going to do is I'm just going to do Docker Compose up over here. Well, actually, I'm in GitHub, so let's go ahead and actually navigate to that new directory, .NET Podcasts Learn Live. And I'm going to say Docker Compose up. Now, what this is going to do is it's not only going to pull those images if I needed them, but it's also going to build them, and then it's going to run them inside of a container that is defined there. And we can see actually now a bunch of output is happening because those services are all running. And if I come back over here, what we'll note is that, like Matt showed you earlier, we have our sort of folder structure here, and we have a bunch of different microservices. In fact, 7 of them. We have the storage, the database, 2 service workers, an API, a listen together hub, and the website, all running on different ports. My images are my images. All my images are right here. And I also have volumes. We didn't talk about volumes, but volumes are sort of like this is the database, basically. It's like a file on disk that's created. And here are the volumes that I have here. So it's the database itself. And this is the Azure storage, Azure Write local deployment here. So this is all running here. So check this out. I literally just ran a command. I'm going to hit this browse over here for the web. And this is going to launch in a browser. And this is running locally on my machine at port 5002. And this is the ASP.NET Core Razor Pages application. And what's cool is that the data is actually coming in real time. So if I actually refresh this, I think if I make this smaller, I guess I'm really zoomed in here. Well, I guess there's only 2. Over here, I can also now hit Discover More. And what we'll see is that we have the same exact application, but running locally inside of my 502, which is really, really neat. I can go ahead and browse. Here's my podcast, Merge Conflict. So again, this is running locally. Here's one we put out today about C# global and implicit usings. I can go ahead and listen to that. Starts playing. I can go and subscribe to this podcast. I see it in my subscriptions. I could also come back over and I could add a bunch of these to listen later over here. And I also can say, hey, I want to listen together to this podcast. So I'm going to create a new room. So I'm going to say James 1. This is kind of cool. Now, if I actually open another one right here, so now we're scaling up. We're scaling up. It's happening. I'm going to log in and I'm going to go over to listen together. And let's say that this was you. You can't do it because it's local, but I'm going to join this room and say James 2. This is going to be communicating with the Listen Together hub via SignalR. And what's cool is that we can listen to the podcast together. You can see as I start one, the other one starts. And I can actually send emojis over here to myself as well. So we can listen to this together. It's a cool way of sharing podcasts interactively together. So everything is just sitting here. And in fact, if I go into, the API, for example, and I tap on it, we can see that there's a bunch of things happening. We can inspect everything that's happening and look at statistics and memory usage. I can go into the CLI like we talked about as well. We can open it up. So you still have access to all those different things right there, but it's kind of nice to kind of see everything running inside of all of these Docker containers as well. So a really full scale application there running as well. So it's really nice. Yeah. And what's nice is that the SignalR Listen Together hub is communicating with a different database and not the main database. So it's a really nice architecture when you scroll down here and you talk about the multiple databases, that the Listen Together hub is managing that database and it's being communicated, through this service. So it's a nice introductory. It's not too crazy. But the one thing I'll talk about that's really neat is that this specifically is using this Azure Container Apps over here. And what's nice about that is that scale on demand. So if I actually show you really quick, one thing that's nice is that we have these deployment services over here. And you can actually run this all in Azure, set a few component variables and things like that, which is really cool. But basically, eventually what I'll show you down over in this file is that is here I'm defining in this big JSON file, basically a container app. And it's going to run my podcast API over here in this container app. And the biggest thing is that it will automatically scale from 1 all the way up to 5. And there's also other ones in here too, like this ingestion worker, which can also scale from 5 down to 0. So those different scale on demand. But it's really cool that you can actually just sit here, check it all out. I'm going to leave this room and no rooms are available. And there's also a dark mode too. Who doesn't love that, Matt? It's all built in.
Now you know it's modern.
Super duper cool. And that's the .NET Podcast app. And you can just get it up and running in just a few minutes using microservices and Docker and containers and all that stuff, and see how it deploys using that. And there's videos that we've also put on the .NET YouTube to walk you through all of that. So that's it, Matt. We totally did it.
Yeah, we did do it, James. I love the podcast app. It kind of takes the next step. It shows you a real world application running. It's not trivial, but it's not ununderstandable either.
Totally.
So, yeah.
Totally.
Love it.
Cool. Well, we're at time. We totally did. That was the perfect amount of time.
Yeah, I thought this is perfect. What a great ending.
Perfect.
All right, James.
Well, thanks everyone for tuning in. Thanks for all the great questions as well. If you have any questions, feel free to reach out to Matt or me. Our Twitter handles are right there. No, over there. There it is. There. Perfect. All right. Have absolutely amazing afternoon, morning, or evening, wherever you're at in the world. And happy holidays. And happy holidays to you, Matt.
Thanks, James. You too. We'll talk later.
Cheers.